Hi, this is Mrs. KJ and I'm going over the 2.01 lesson, Solutions. Solutions, which are important parts of chemistry in everyday life, demonstrate how matter interacts. Most drinks are made of water with sugars and other solids dissolved in them. How do solids dissolve in water? What factors speed up or slow down the dissolving process? Solutions are all around, from a glass of lemonade to seawater. In this unit, you will learn the definition of a solution and much about the chemistry of solutions. Lesson 1, Solutions. A solution is a homogeneous or homogeneous mixture. Solutions are composed of a solute dissolved in a solvent. Solutions can be described as being dilute or concentrated. Examples of solutions are all around you. You will see in this lesson there are many properties ascribed to solutions. Sorry for all those side beeps from my computer. I think I fixed them all now. All right, goals for this lesson. Define the terms solute, solvent, solution. Give examples of solutes, solvents, and solutions. Define concentration. Describe two ways in expressing the percent concentration of a solution, which can be volume-volume or mass-to-mass. Express the concentration for a given amount of solute and solvent. Define the term saturated solution. All right, so we have a solution which needs to be a homogeneous mixture. And what does homogeneous mean again? It means that it's the same throughout. So if you take a drink, the very first drink tastes exactly the same as the very last drink. There are no layers, there's no differentiation between different concentrations at the beginning, the end, it's all the same. And what is it composed of? A solute and a solvent. And then of course there's some links that you can click to get some of your stuff. And we will look at our notes. So again, feel free to hit pause and use whatever you'd like for the 2.01 solutions. So first of all, saturated. A solution in which the greatest possible amount of solute is dissolved. So in other words, no more sugar can dissolve. Why? Because it's saturated. Because it's full. There's no more room. Okay, so there is no more room. And the extra, what's going to happen to the extra sugar? It's going to sink to the bottom of the glass. All right, we have a solute. A solute is a substance that dissolves in a solvent. A solvent, let's skip down to this one, is a substance, usually a liquid, that can dissolve other substances. I always like to think of my example as water. So solvent is my water. And if you learn some other languages, you know that the W sometimes makes more of a V sound. So I always think a solvent is my water. And the solute is the stuff that dissolves. So for example, this would be the sugar. Then we have a solution. A solution is a homogeneous mixture. And so we'll just kind of remind ourselves that that is the same throughout, in which the substances are completely and evenly mixed down to their individual molecules. And then I added this down here. Solvents dissolve solutes into solutions. In other words, water dissolves sugar into lemonade. And obviously more than just sugar, but you get the idea. So our solvent is water, our solute is sugar, our solution is the lemonade. Then we can also have supersaturated, a solution under specific conditions that contains more solvent than exists in a saturated solution at room temperature. So in other words, saturated meant we couldn't dissolve anymore. Well, you can super saturate it, or in other words, you can force more to dissolve than should be able to. So you can change the temperature, the pressure, and make it super saturated or extra saturated. So again, then I just copy pasted our goals down here. And let's go ahead and go back to our lesson. Solutions are all around. What do seawater, the blood coursing through your veins, an ice-cold glass of lemonade, and a powerful acid have in common? All these substances are solutions. A solution is a homogeneous mixture of two or more substances in one physical state. Homogeneous mixtures do not contain parts that are visibly distinguishable. Think about lemonade. Now, okay, so you got to think of like the powdered stuff. Don't think of the homemade stuff with chunks. Okay, you got to think of the powdered stuff. So think of lemonade. You can try all day, but the chances of identifying individual particles of sugar, water, and lemon juice molecules in that substance are low. Lemonade is a homogeneous mixture. It's a solution. A solution is composed of a solute and a solvent. Remember, the solvent is our water. In a solution, one substance is mixed with another substance. The substance that is broken down or dissolved is called the solute. The substance in which it is dissolved in is called the solvent. In a sugar solution, sugar is dissolved in water. The sugar is the solute. The water is the solvent. So we're going to just copy paste that sentence right there into our notes. In salt water, a solid, sodium chloride, is dissolved in the water. So water is the solvent, sodium chloride is the solute. Soda is also a solution, as in like soda pop, like Mountain Dew. In soda, the solute is a gas, carbon dioxide, which is dissolved in the liquid solvent, water. So they can be gases as well as liquids, which is kind of interesting. So let's put that example down too. And solutions dissolve the solutes at a molecular level. Solutions can involve solids, liquids, and gases. You might think that all solutions are solids dissolved in liquids, but in fact there are a number of solutions that involve other phases of matter. The table shows examples of different types of solutions. As you can see, there are examples of solids, liquids, and gases as both solvents and solutes. Alright, so solute. Argon gas dissolves in air. Seltzer is another example. And this time it's a liquid that has dissolved the gas. And now if we have a gas dissolved in solid, that would be smoke. Alright, so what if we have some liquid? Water droplets in the air. That would be an example of a liquid dissolved in a gas. You could have fruit juice in water. Or yogurt is an example of the liquid dissolved into a solid. And solid you can actually have in the air, like the dust. You can have the solid sodium chloride dissolved in liquid for seawater. And you can have gold and silver alloys dissolved, so you have a solid and a solid. Solutions can be different combinations of solids, liquids, and gases. So if you'd like, you could put this into your notes as well. A solution can be described in qualitative terms. As you probably know, sugar water will be too sweet if too much sugar is added to the solution. When making sugar water, you have to keep in mind the amounts of the solute and the solvent. If you are discussing the amount of solute and the amount of solvent, you are talking about the concentration of a solution. Weak, not very sweet sugar water is said to have relatively low concentration of solute, in this case, sugar. So in other words, there's not enough sugar, it doesn't taste very sweet, it has a low concentration. Strong, sweet sugar water has a relatively high concentration of sugar. A solution with a smaller amount of solute is a dilute solution. One with a greater amount of solute is called a concentrated solution. The terms dilute and concentrated are, of course, relative, because it could, for example, be according to how somebody says it tastes. All right, so I added this to our notes. The terms dilute and concentrated are relative. A dilute glass of Kool-Aid didn't have enough powder or solute dissolved in the solvent, so it tastes weak. A concentrated glass of Kool-Aid has a lot of powder dissolved in the water. It tastes very sugary and overly delicious because it is concentrated. The lemon flavoring molecules in lemon juice are relatively concentrated because you just have one drop of lemon and you can taste it, right? I mean, on your tongue it's like, ooh. And that's because there's a lot of the molecules in that one little drop. It's concentrated. The lemon flavoring molecules in a pitcher of lemonade are relatively dilute, so not nearly as strong as if you are just sucking on the actual lemon. A solution can also be described in quantitative terms. All right, so qualitative is like quality. So for example, taste. Quantitative is numbers. The term dilute and concentrated are qualitative, non-numerical measurements of concentration. For chemistry work, the concentration of a solute in a solvent is often expressed in terms of a percentage, a numerical or quantitative measurement. For example, a 3% saltwater solution contains 3% salt and 97% water. There are other more informative ways to express the concentration of a solution. If 6 grams of salt is added to 1 liter of water, the concentration can be written as a mass to volume ratio, 6 grams per 1 liter. So in other words, they took 1 liter of water and they added 6 grams. So they call it 6 grams per liter. Or another way that you can do it is by percents. Either way, you're using numbers, so it's a quantitative representation of concentration. So a solution can be described in quantitative terms. For example, 4% salt, 96% water, or 5 grams of salt is put in 1 liter of water, and so we call that a 5 gram per liter solution. Solutions with a liquid solute and a liquid solvent are described by volume-volume ratios. When a solid solute is dissolved in a liquid solvent, okay, so when you put sugar in water, the concentration can be described conveniently in terms of mass volume. Or in other words, we say grams of the sugar divided by however many liters of water you put it in. If 2 liquids form a solution, though, the solution is best described in terms of volume-volume. Common rubbing alcohol, for example, is typically a 70% solution of isopropyl alcohol and water. This means that there's 70 milliliters of isopropyl alcohol for every 100 milliliters of water. That is, in 100 mils, there are 70 mils of alcohol and 30 mils of water. Basically, it's the same idea, except now we're just doing liquids, right? So liquids, we could say in 1 liter of solution, I have 500 milliliters of water. We should probably make them different. Hang on. I have 700 milliliters of water and 300 milliliters of alcohol. And it's isopropanol, or you guys are probably more used to calling it rubbing alcohol. So this one we would call a mass to volume because we use grams and liters. This one we use milliliters and milliliters, or liters and liters. Therefore, it's simply called a volume-volume ratio. So it's all about looking at what the units are. Sometimes a solution may become saturated. Try this simple experiment. Take a small amount of room temperature water. Add sugar a teaspoon at a time, and as you go along, stir to dissolve the sugar. As you keep adding sugar, you will notice that at a point will be reached when no more sugar can be dissolved. The solvent, water, cannot hold any more of the sugar in the solution. This solution is now said to be saturated. A saturated solution is one in which the solution cannot possibly dissolve more solute under the existing conditions. Temperature plays a role in the ability of a solution to become saturated. If you were to try the same experiment with warm water and sugar, you would find that solution could hold more solute or more sugar would dissolve. Temperature can influence the ability of a solution to hold solute, or in other words, to cause it to dissolve. So I added a saturated solution is one in which the solution cannot possibly dissolve more solute under the existing conditions. However, the higher the temperature, the more that can be dissolved. It is possible for a solution to become supersaturated under the appropriate conditions. What might happen when a bottle of soda or seltzer is uncapped? It is quite possible that when the pressure is released, the soda will effervesce out of the bottle as the carbon dioxide in the solution rushes to escape. The soda or seltzer has been put under great pressure and then sealed. Carbon dioxide has been forced into the soda. In fact, the conditions of high pressure allow more carbon dioxide to be pushed into the solution than would be possible under room conditions. In other words, the soda solution is supersaturated with the solute, and when the pressure is released, the gaseous solute rushes out, sometimes creating a messy geyser of soda, or sometimes it's just when you open it and you hear that psh, right? That's because the gas was forced in, and it was forced to become supersaturated, so more dissolved than really wanted to, which is why when you open the can of pop, you allow it to escape. Okay, so those of you that have listened to these before, you know I'm only allowed to record 15 minutes at a time with this program, so we'll finish the rest up in the next video.